Hello. In this lesson, we will be talking about chemical reactions. We'll introduce what a chemical reaction is and the signs that tell us a chemical reaction has probably taken place. A chemical reaction takes place when one or more substance turns into one or more entirely new substance. This takes place when the bonds of the original substance are broken apart and the atoms in those original substances are rearranged. When these bonds are broken and the atoms are rearranged, we know that the chemical structure of that substance has changed. Hence, the identity of that substance has been changed into something entirely new. Let's look at an example. We can see here that we have a couple of hydrogen molecules and an oxygen molecule. These are the original substances in this reaction. Over the course of a chemical reaction, the bonds in these original substances will be broken apart. Their atoms can then rearrange into a new configuration, which represents an entirely new substance. In this case, we can see that our hydrogen atoms and oxygen atom have reacted and rearranged into two molecules of good old H2O or water. In a chemical reaction, we have two types of substances. We have those original substances that we just discussed, which we call the reactants. These are those old or original substances which will have their chemical bonds broken apart and their atoms rearranged into something new. Here's another example. In this reaction, we can see that we start off with a methane molecule, which is CH4, and two oxygen molecules, which are just O2. Over the course of the reaction, these reactants, again, will have their bonds broken, their atoms rearranged into what we call products. These are the new substances or the substances that are produced in the reaction. These are where the atoms have been rearranged, new bonds have formed, creating entirely new substances with an entirely different set of properties. If you think back to our previous unit, we know that if two substances are different, they have a different set of properties. Hence, the products in a chemical reaction have entirely different properties than the reactants that began in the reaction. In this example, we can see that our CH4 and O2 molecules have now changed into CO2 or carbon dioxide and two water molecules. Here we can see a chemical reaction from start to finish. We can see that we have a couple of hydrogen molecules and an oxygen molecule whose bonds have been broken apart, and now their atoms are beginning to rearrange. Once they're in the correct configuration, we can see new bonds are formed, resulting in those product compounds. One last thing to keep in mind in a chemical reaction is something called the law of conservation of mass. You will also see me refer to this as LOCOM or LOCOM as an abbreviation. The law of conservation of mass tells us that matter in the universe is neither created nor destroyed. This means that the amount of matter that is present in the universe is constant and never changing. When it comes to a chemical reaction, this fact means a few things. First, it means that over the course of any chemical reaction, the total number of atoms does not change. That means the number of atoms in the reactants is exactly the same as the number of atoms in the products. It also means that the type of atoms do not change. So although bonds have been broken and atoms have rearranged into new configurations representing new substances, the type and number of atoms that are present remains constant. Finally, this tells us that the total mass of the products is equal to the total mass of the reactants. This has to be true in order to support this law of conservation of mass, meaning that mass never changes. So the mass in the beginning of the reaction is exactly the same at the end of the reaction. Let's look at one more example, our same reaction here. So we can see our methane and our oxygen atoms are our reactants in this reaction. We can see that in those reactants, we have 4 oxygen atoms present, 4 hydrogen atoms, and 1 carbon atom. We can also see that that equals a total of 9 atoms. Now, over the course of this reaction, we know that those bonds will be broken apart. We know that those atoms will rearrange into new substances. However, if we look at our products, we can still see that we have 4 oxygen atoms present, 4 hydrogen atoms, one carbon atom and a total of 9 atoms. Since the type and number of atoms are the same, we can also assume that the mass of those products is exactly equal to what it was in the reactants, supporting what we now know as the law of conservation of mass. Now, in an upcoming video, we will discuss how we can actually prove that a chemical reaction has taken place. However, there are some signs or pieces of evidence that can tell us that a chemical reaction has probably taken place. When two substances interact and we see any of these signs, it tells me that there's a high likelihood that a chemical reaction may have taken place. The first piece of evidence is a color change. That just means that, again, if two substances interact and I see the color of the substances change, tells me a chemical reaction might have taken place. Next is a change in temperature. This can either be an increase in temperature, or the substance is getting hotter, or a decrease in temperature, meaning the substances get colder. Next is the creation of a gas. Now, this can either be a visible gas rising up off of the substances that are interacting, or if it is a liquid, oftentimes we will observe this in the formation of bubbles coming out of that liquid. Next is the formation of a precipitate. We won't focus much on this one, but a precipitate is when one or more liquid are mixed together and a solid actually forms out of that liquid. Now, this is different than freezing. This means that with no change in temperature, a solid actually formed from the mixing of these two liquids. Finally, the production of an odor. Now, my emoji indicates that this is always a stinky odor. However, that's not always the case. Any sort of smell that occurs or is produced when the substances interact tell me that it is likely that a chemical reaction may have just happened.